here's our full model of our Halo Reach Scorpion tank. It has all the treads on the bottom have full mobility, and the turret on top has full mobility as well. The treads on the bottom are powered by an RC remote controller, and the turret is just hand powered where it rotates on a bearing where you can move it however you like. Here's just a quick video of if you watch the wheels, they're able to go both forward, backward, and then it can turn left and right with the wheels going in opposite direction. So the wheels are able to go, right now they're all going, everything's going forward, the turret's spinning. Now it's switched to them going backward right now, and the turret's going the opposite direction. And now the two wheels are spinning in the opposite direction so that it's going to turn right, and then it's going to switch again and it's going to end up turning left. And now Ryan's going to talk about more about the actual features of our actual model that we created.
Should I have the toy with me?
No, you can just and the toy's over there with.
Yeah, basically with this we just wanted to. You guys can just look at the screen. With this we basically just wanted to make sure the most important thing was the tank cover, the tread covers. We need to make sure that the tread cleared everything and fit properly, and nothing interfered with the motion of the RC card. So, and priority number 2 was detail, so it looked sweet. And as you can see, there's as much detail as we could put on here. We've got that little gun that you can shoot from, the driver's window. We even put those handlebars. There's hinges on the flaps on the sides. There's the grates, the lights even. Yeah, we pretty much just try to focus on, once we thought that we'd had the tread all figured out and the clearance issues figured out, we just try to make it really look awesome. And that's about it.
And now
so you
yeah. And now we're going to show a demonstration of our tank moving with the RC controller.
When we were sanding down these track covers, we broke off the back ones, so we figured we'd just keep these off. For actual motion, the back ones stay off. But it's going to be hard to see if anybody wants to come around, but it does actually go forward, backward, and turn left and right. The turning motion's a little difficult, just it's not heavy enough for the track, but you can, if you get the treads going in different directions, it will actually turn for us. And then it goes pretty decent speed forward and backward. And then Zach can operate the turret for us.
Rotate the turret by hand.
There we go.
Yeah, we're actually using a hard drive motor, not a hard drive, a disk. We were hoping that we'd get the turret to move, but apparently you need more than just a voltage to get those motors to work. So that was a little too complicated. But yeah, that's about it.
Questions? Okay, thank you very much.
Alright, so what we did was a dancing gopher. So what it does is it moves its arms up and down while twisting left to right, and also the head pivots left to right. So the way we got this motion was we had a one gearbox with 4 bevel gears, each gear driving a shaft that rotates the arms, head, and body. And we used one crank rocker assembly to get the oscillating motion. And then, just want to talk about how we modeled it.
Yeah. As you can see, the body has been modeled in 2 parts, and they're both symmetrical. That way we could assemble everything inside and then put it all together. The arms are also 2 separate parts apiece. That way we can make sure they fit well in the physical model. And then the head was modeled using a variable section sweep to get the nose So that was basically a trapezoid, which was swept to most of a circle, and then used revolves for the eyes, and then more sweeps for the nose and the mouth features, and as well as the teeth.
The rest of it, all of the gearbox and everything is driven off of one motor to allow for kind of a compact design. Here you can kind of see how it all works together. The thing to kind of notice is that the head also actuates at a different speed comparing to the body, which you can also see here.
Talk about construction.
So obviously we covered up most of our SLA with this fur, so you almost can't even tell that there's SLA underneath it. We really tried a little bit to make some texture in Pro E, and it was just way too much data going in, and we didn't think it looked very good painted. So this is just to show you guys what's inside. It's all bonded together. We can't really take it apart. So this is the gearbox he was talking about. Everything's enclosed. There are 4 bevel gears inside, and it's all just affixed to the base. So that's everything before we put the fur on, everything enclosed with the arms, and you can see all the SLA parts. And then also in that last one, the main mechanism, the crank rocker, is SLA linkages, so that's our main motion for our SLA parts.
Do we want to show the, so here's just our video of the mechanism.
Seems like its head turns more than that. Does it?
Does its head turn more than that?
Yeah, than the actual head.
No. It just kind of looks like it because of the fur on it. Without the fur, it looks exactly like this. Any questions?
Any questions?
Any questions? Okay, thank you.